Hey everyone, welcome. Today we're going to tackle one of programming's most powerful and maybe a little intimidating ideas, polymorphism. I know it sounds super complex, but I promise you, the actual idea behind it is incredibly simple. By the time we're done here, you're going to get it, for real. So let's just dive right in.
So here's our game plan. First, we'll break down the word itself. Then we'll use a super simple analogy to see how it works in the real world. After that, we'll look at how you actually build this in code, uncover the secret sauce that makes it all work, and finally, talk about why this whole concept is a total game changer for you.
All right, first things first, let's talk about that name, polymorphism. A lot of times in programming, the scariest sounding words are actually hiding something pretty straightforward. And that is absolutely the case here. Now, if you look it up in a textbook, you'll get a definition like this. Something about objects of different classes being treated as a common superclass. Yeah, that sounds pretty academic, doesn't it? Honestly, don't even worry about memorizing this. We're going to get to what it really means, and it's way more intuitive. Because the whole secret is right in the name. If you break it down, it comes from two Greek words, poly, which just means many, and morph, which means form or shape. So polymorphism, it literally just means many forms. That's it. One single idea that can show up in many different shapes. See? Not so scary after all. Okay, so keeping that many forms idea in our heads, let's step away from the code for a second. Let's use a really simple, real-world example to see what this actually looks like. So let me ask you a question. Imagine you have just one single command you can give, make a sound. What do you think happens when you give that exact same command to a bunch of different animals? Well, if you tell a dog to make a sound, you get a pretty specific response, right? You get a woof. The action we asked for was general, but the result, the form it took, was unique to the dog. And what if you give that exact same command, make a sound, to a cat? You get a totally different result. Meow. And this right here is the whole idea in a nutshell. We have one action, make a sound, but it results in many different forms depending on who we're talking to. One action, many forms. That's polymorphism. Okay, so the whole animal thing makes sense. But how in the world do we actually build something like this in our code? Well, to get polymorphism to work, we have to set up a kind of family structure for our objects, specifically a parent-child relationship. And we do this using a concept called inheritance. It's really just a simple three-step recipe. First, we make a general parent class. We can call it animal. Think of this as the main blueprint. Second, we create our more specific child classes, like dog and cat. And third, and this is the most important part, we make sure our code knows that a dog is a type of animal and a cat is a type of animal. They inherit from their parent, just like a family tree. So we've got our family set up. We have an animal parent, and we have dog and cat children. But how did the dog and cat actually provide their own unique sounds? Well, this is where the real magic happens. It's through a cool mechanism called method overriding. Method overriding is actually a pretty simple idea. It just means that a child class can provide its own special version of a method it got from its parent. So the parent animal class might have a generic idea of how to make a sound, but the dog class can basically say, hey, thanks for the suggestion, but I've got my own way of doing this. It gets to have its own voice. If you look at this table, you can see exactly how this plays out. Our parent animal class has that general make sound method, but then the dog class comes in and overrides it to make a woof, and the cat class does the same thing, but it overrides it to make a meow. Each child is providing its own custom version of the exact same action. And by the way, this whole technique, where the program figures out which specific sound to make while it's actually running, that's called runtime polymorphism. It's the most common and, honestly, the most powerful type you'll use. Okay, so we get what it is, we get how it works, but why? Why should you care? Why is this such a fundamental part of programming? Well, this is where we get to the good stuff, the practical benefits that are going to make your life as a developer way, way easier. First up, code reusability. You can write a single piece of code that just says, hey, for every animal I have, make a sound. And it just works. It doesn't care if it's a dog, a cat, or a duck you decide to add next year. This gives you insane flexibility. You can add a new duck class that quacks, and you never have to touch that original code. This also makes your code so much cleaner. You get to avoid those giant, messy if-else blocks like if it's a dog, then bark, if it's a cat, then meow. And when you put it all together, it means your projects are more scalable and just way easier to manage as they get bigger.
So if there's one thing you take away from this, it's this. Polymorphism isn't just some fancy academic term. It's a powerful way to design your code so that it's clean, flexible, and ready for whatever changes you need to make down the road. You're basically future-proofing your work. So I'll leave you with a final thought to chew on. Think bigger than just animals. What if you had different kinds of shapes that all needed a draw command? Or different user types that all need a login action? Now that you know how to make one single action take on many forms, what kind of powerful, elegant new things can you build?